Good day, everyone. Welcome to GeoTutors. So, on today's episode of GeoTutors, we are going to look at how to plot our seismic data plot on a graph. Okay, so this is the forward and this is the reverse short distance time table. Okay, X is for distance, T is for the time. Good. So, first off, we are going to start from. So you're going to plot it. Now, I'll just give you the hint about guidelines that you just need to follow when you're plotting. So now, when you have your forward shot, your first shot starts, your shot, the total of your shot, let's say we have, this is where your shot is, right? Good. To the last geophone, that is what we call the total spread length, everything all together. So, and that is your total distance. That is why on your graph, you are going to draw a line. Okay, your x-axis, distance is always on the what? X-axis. Y time is on the what? Y-axis. Or let's say time is on the vertical, distance is on the what? Horizontal. Okay, so your distance is going to start from 0 because that's the beginning of your forward. They started from 0 to the last geophone. Where will the last geophone be? Last geophone is at what? 48 meter. That's what we got the reading. The last geophone. So that's where the last geophone is. We have a lot of geophone in the middle, a lot of geophone, a lot of geophone, a lot of geophone, a lot of geophone. Then the last geophone, 48 meter, from 0 meter to 40. So the total spread length, that is what your distance will be. The total spread length. Then the next step you're going to take is now, when you've done that, let's say this is your graph now. You've done this, take this to your 0, you rule a straight line, any place, a vertical straight line. Then 0 to, the last one was 48, have you? You're going to use your forward as forward, is taking forward distance timetable is okay. So 48 is where it stops, right? And you, on that 48, distance 48, you're going to rule on that straight line, vertical what? Straight line. You see that vertical straight line. So that is how you do your plot. You draw your graph plot. Now, then normal, you know what to do. Take your scale, normal graphs method. So two, this forward. Forward is starting here, reverse from here. Okay. So now for forward, we have at 0.26. So my scale for this guy, I used 2 centimeter represents what? 10 units. I use 2 centimeter represent 10 units. 2 centimeter represent 10 units for both my x-axis and my what? Y-axis. That's what I used. Okay, so 2, 6, 4, 10, 6, 14. All of this you plot the graph. Then we now got this plot. Good. Now, after getting your plot, now this for the forward. After getting your forward, what you're going to do is line of best fit. Line of best fit. You don't have to join all the points together. Line of best fit. But you can see your value when it is, you can see that it's giving a shape like this. Something that moves like this, then moves like this. Something like this. Okay? So, which means you just need to just get the first one. You can see there's another one like this. Let's see. Line of best fit, it should just touch almost everything. So let me see that. That's line of best fit. Okay, good. Done that. And remember, it must start from 0. When you are drawing from here, it must start from what? From 0. It must start from 0 to the first layer break. Then from that layer break to this edge. Just know you must start from the 0, because for forward shot is at point 0. At point 0, that is where your shot was. You have your geophones at point 0, 0 meter. before you now start doing geophone spacing, different. So that's why you must join it to what? Okay, so this one to you do your line of best fit. Which line join them was from zero? Okay, can you see that? Good. Now the same thing you do from here too. Because for reverse, you're going to start from the last geophone. For reverse now, reverse. Forward is like this, Abi. Your short is here. Let's use an example. This is zero meter, Abi. From here to the first geophone, let's say just say it is 2. Then all that geophone spacing, maybe everything 2 meter, 2 meter, 2 meter, 2, 4, 6, 8, then 10, Abi. Good. So now the next step now you're going to take is this for forward, this is the method. So when you're doing reverse, you take this, your shot will not now be here. This where this last geophone is, you're going to move all of them forward. So the first geophone now is not be at 2 meter again, it will now be at what? At point zero. The second geophone will not be at 4 meter, it will be at 2. The third geophone, okay, we have 1, 2, 3, 4, 5. Have we? Will be at 4. The next one will be at 6. Next one will be at what? 8. And the shot will now be at that position what? 10. Now be at position 10. That's where your shot will be. That's why we are starting from where our last spread is. This is reverse foot. Sorry, I say reverse foot. Reverse shots. Okay. So line of best fit. Line of best fit. Line of best fit. And do this first. Anyone want to do? Okay. Good. And do this. The break to this place. Good. You've seen that. So simple and so easy. So you just line of best fit, making sure that where most points lie on it, or sometimes it might not even like lie on most points. You're just trying to rule a line that cut across equal spacings. Okay, line of best fit. Good. Now, this is not the focus. You've done a distance timetable. We've gotten how to draw our line of best fit and the rest. Now, this is for 2 layer. That's why it's like just 1, 2. If it's for third layer, you see on that breaking again, the third one. See on that breaking again, third one. But it's just for 2 layer. Okay. Um. Now we're not yet done. Next step is now for us to get our velocity. Okay. Velocity. You get your velocity. So you get want to draw a table. This is forward. This is reverse. Okay. So since it's 2 layer, we have V1, V2, okay, and only one distance, depth, V1, V2, Z. So these are questions, these are things that they will ask you to find, okay. Short, forward or reverse, what are the velocities and what is the depth that you get. Good. So now you're going to do a slope. Now let's start with forward. Make sure first thing to note, ensure that what your slope is big to avoid error. So big to avoid error. So big to avoid error. So that's the first thing you need to do to ensure that what is so big to avoid error. So if you have something like this, so I make sure that I use a big slope. It should not be small, it should be big. Okay. Then we have on that one here. Take this guy. Can you see that? So good. Hmm? That's those are our two slope. We do for these ones too. The same thing for the reverse shots. Doesn't have to be in the same location, but just make it big. That's all that matters. That's what matters. Okay. Okay, good. Now we'll do for this side also. Um, yes, good. Okay, so this are slope for forward, slope for reverse. Okay, now I'm going to go into calculations and some solvings. But before that, some things that we need to find. So to make something so clear, slope is equals to 1 over velocity. What I say, slope is equals to what? 1 over what? Velocity, right? So now we're going to solve for each one of them one by one. So let's start with a forward shot. For forward shot, let's find for slope of velocity 1, Abi, which is this guy, the first one, is that one, slope of velocity 1. So since slope is equals to 1 over v1, right, is equals to, now you remember the formula for slope now. Slope is y-axis over what? X-axis, right? Y2 minus y1. So this one, since it's time, it will be what? T2 minus T1 over what? D2 minus what? D1. So now let's get our T2 and our T1 for it. Okay? So now this is our D, Abi. This is D. So trace it down. I see it. We trace this guy down. So we get our first D2. We come here also, trace it down also, get our what? D1. Okay? So this is 1, 2, 3, 4, right? D1 here is 4, D2 here is 18. So 18 minus 4. Now T2 minus T1. What's our T2? We come here, the highest point here, can you see? Towards this place, take broken lines. Okay, that's like 40. So here T2, and you come here so it's exactly at 10. These are T1. So T2 is 10, T2 is no T1 is 10 milliseconds. Okay, and T2 T2 is 42 milliwatt seconds. Okay, now this is one thing you need to take note for in the exam. You should not get your final answer in better for you to convert your milliseconds to seconds. Don't leave it in this. It's not a standard unit. Okay, so normal in seismic we get our time in milliseconds, so you have to convert it to seconds. Okay, so now what you're going to just write here is 42, Abi, 42 minus 10, right? Milliseconds. 42 minus 10 milliseconds. So that will give us what? 32 over what? 14. 32 over 14. Don't forget your milliseconds, though. We're going to convert it. 32 divided by 14 gives us 2.285. But this is 1 over what? Velocity, right? 1 over velocity. 1 over velocity. So here is what? Milliseconds over what? Over distance, right? That's the distance, which is like times 10 raised power minus 3, right? Seconds per meter. 10 raised power minus 3 seconds per meter. Time is up. So 10 raised power minus 3 seconds per meter, right? So now, the inverse of that will now turn to what? 1. 1 over v will now turn to v will now be equal to what? 1 over what? What is here? Which is what? 2.285 times 10 raised to power minus 3. You now get your answer. So 1 divided by will give me what? 0.4375 times 10 raised to power what? 3 meter per what? Seconds. So 10 raised to power 3. 1, 2, 3. That's like 437.5. Can you use your calculator to get that? Meter per what? Seconds. Okay, so just make sure that you clear the milliseconds issue. We get that slope, right? So you're going to do the same thing for, okay, let me just complete V2 also. So we've done for this guy, so let's do V2 here. So for V2, so I've done for V1, so sorry, I'm supposed to write V1 here. Okay, so let's do for V2. So V2 will now become, this is not your V2, this is for reversal. Okay, this is V1 for reverse, V1 reverse, V1 forward, V2 forward, V2 reverse. Okay, don't write like this in your exam only, but just take note, like you can clean it after you're done. Okay, so now let's look for the second slope. This is our second slope, right? So we know that this guy picked at this point. Okay, exactly at that point. This will be our T what? T2. At this point, this will be our T1. Okay, let's get our distance. Our distance will be this. Trace it, broken lines, broken lines, broken lines, broken lines, broken lines. Towards this down. That's like at, this is 48, Abi, at 46. Okay, and this guy at 21. At 21. Our D1 will be at, this is our D1. Okay, here is 20, and you know that this is increasing by 1, 1, 1, 1, 1. So here will be 21. Here will be, this is 48, Abi, this is 50. And here is 47, here is 46. Okay, so slope for the slope is equals to 1 over V2. We're focusing on this forward now, forward, which is equals to T2 minus T1. T1 will be what? Let's get our T1. Um, let me count it. Yes, 40, Abi. Yes, 40. 41, 42, 43, 44, 45, 46. Okay, you have 46 and 79. 46 and 79. So T2 minus T1 is 46 minus, sorry, 79 is 42. 46 for that other guy. Then we also have 46 for our D, for our D2. Then our D1 is 21. Is 21. And remember that these guys are in what? Milliseconds. So I can solve this in another way again. You can choose to wait till this point before you put your milliseconds, or you be like me. This is what I do in the exam. I just apply my milliseconds at once. So I just do 79 times 10 raised to power minus 3 minus 46 times 10 raised to power minus what? 3 over what? 46 minus what? 21. So I press my calculator. This gives me 0.033 over 46 minus 21. That's 25. Okay, remember this one over what? V2. So what is 0.033 divided by 25 give us? That gives us 1.32 times 10 raised to power minus what? 3. Okay, so we're not looking for 1 over V2, we're looking for what? V2. And this is one of the mistakes that many people usually do in exam. I'm not lying. And funny enough is that you can also do that same mistake even after listening to me. Because in exam, there's a lot of tension. So that's why you need to practice this stuff over and over again. because so that when you are just because many people when they just get this final answer, this one here, they are forgetting that it's not slope they are looking for. It is what v2, and slope is 1 over v2. So 1 divided by 1.32 exponential minus 3. So that gives us 757.6 meter per second. So we've gotten our velocity. Okay. Now the next thing that we need to get is what we call our depth. You can see v1, v2, and z. Our depth. And how do we solve for our depth? The formula for getting depth is given as z is equal to, that for two layer, this for two layer, t subscript I, v1, v2 over 2 square root 2 times the root of what? 2 times the root of v2 square minus v1 square. Okay, so we're going to put this guy inside root. Now what is ti? Ti, you can see ti is the intercept. Is the what? Intercept. Now remember that when you are sketching your stuff, you know that this is what you have, Abi? The rectangle. Okay? You know you have something like this. It now broke like this, right? So moving this way, then deviated this way. This part of deviation, you're going to take a slant ruler. Slant ruler. Continue that trace. Can you see? Continue the what? The trace. You continue that trace to the y-axis. That point that you get is known as your what? Your ti. So now let's come to our own stuff. This is where it's broke, Abi? Yeah. I'm going to continue the trace. Can you see that? Continue the trace. Okay. So it's almost 21. Okay, no, not 21, sorry. It's below 20. That's like 19. 19. So our TI for the forward is what? 19. Can you get for TI for reverse? For reverse, you still do the same thing. Can you see this part? So moving this way, but it's bent this way. So you're just going to continue this one till you reach that line. Okay. Okay. So it's like 21. For reverse, it's like 21. Okay, reverse. But like we're just doing forward. So TI is 19. All right. So now Z is giving us TI times V1, V2. And don't forget, it's still T. And since it's T, since it's time, it's not just 19, it's 19 milliseconds. So convert it to seconds, that's 19 times 10 raised power minus 3 seconds. Now you can see very well that, so just substitute your values. In our former stuff, we got, so let's just substitute our values first. 19 times 10 raised power minus 3 times V1. What do you get in our V1? Now V, we got 437, have you? 0.5. 437.5 times 757.6 over 2 times what? Square root of what? V2 square, have you? So these are V2, have you? 757.6 all square minus 437.5 all square. Ensure you press your calculator judiciously. 3 times 437.5 times 757.6. So this gives us 6297.55 divided by 7.6 whole square minus 437.5 whole square times 2. 1237.01. So 6297.55 divided by 1237.01 will give us what? 5.09 meters. So write 5 here. Okay, you have to fill a table. So ensure you fill the table so that you don't lose your mark. Okay, 5. Your forward is your forward V1, which is 437.5, V2 757.6. Okay, so your own task is to now do the reverse. To do the what? To do the reverse. Do the reverse of the shots. Okay, do the reverse part. Also fill in the table. You can comment your answers in the comment section. And we've come to the end of the video. Thank you very much. Kindly subscribe and share my video to your friends and your fellow Geophysics.